Good evening, everyone. Can you all? Am I audible to all of you? If you all can hear, please respond. If I'm audible to all of you, please respond. Keep responding. Okay. All right. It looks like that you all can hear me now. All right. So today, what we are going to do here is that we are going to revise the entire formula of the geometry. Now, there is nothing new. I'm not going to teach you anything new at all because it's not the time to learn anything here. It's better to stick to whatever you have learned till now. तो अभी तक जितना कुछ भी पढ़ा है बस उसे रिवाइज करने वाला हूं एंड so what I have done is nothing but I have compiled all the slides, okay, which I have discussed with all of you in the lectures, regular lectures में जितने भी formulas, सारे concepts, सारे theorems किए थे, all the slides I have compiled and we'll discuss those in 2 hours here. All right. And therefore, for algebra, remember in algebra, there are not too much of formulas are there. Geometry is one topic. When it comes to the revision, for example, if I'm talking about the revision here, okay, what all topics needs to be revised here? Now, when it comes to the English section, for example, VARC, there is nothing to revise. If I say, okay, what is there in a revision in reading comprehension? Is there anything to revise in reading comprehension? No. Reading comprehension में क्या revise करना है? कुछ भी नहीं करना है. ठीक है. Similarly, verbal ability में there is nothing to revise here. Same thing goes for the logical reasoning and data interpretation. There is nothing to revise in data interpretation and logical reasoning here. The only area wherein you need to revise something here, that is quant. And in quant too, that too in the geometry, because in the geometry there are lots of formulas are there and lots of theorems are there. So that's why I thought, okay, let's spend around 2 hours with all of you and we can discuss all the important formulas and theorem. Okay, that is just the brush up of all these things. If you all have already prepared your own notes from the lecture, then I'm sure that you don't need to attend this year. You can just refer to your notes. But अगर notes नहीं prepare किए हैं या फिर लगता है कि नहीं 2 घंटे में खुद से नहीं कर पाएंगे, so probably we'll revise here. Okay, so let's go through, and then if you need it for algebra, then we'll see. Because in arithmetic again, there is no such great number of formulas are there. Arithmetic में कुछ है नहीं formulas ज़्यादा. ठीक है, ज्योमेट्री में रहता है, algebra में थोड़े बहुत रहते हैं formulas. Otherwise, most of the things are easier. So, should we start now? नहीं ना सूरज, it's not a time to discuss the questions ना. Questions already class में बहुत सारे कर चुके हैं. So again, I'm not going to discuss any questions here, guys. Remember one thing. If you're expecting me to discuss some questions, no. अभी now it's not the time to learn something. मतलब कुछ भी करने का नया करने का जरूरत नहीं है. जितना कर चुके हो, that is more than sufficient. That is more than sufficient. You just need to concentrate on your strength areas. तुम्हारी क्या strength है? Okay. If you concentrate on your strength areas, I am sure that you all can do great. Okay. So I'll take a short session on algebra where I can discuss all the important points, okay, which you might have forget here. All right. So let's start with the geometry here. Okay. So in case of geometry, I have compiled all the formulas and everything, so we can see it here. Okay. So let's start with the first of all triangles. We all know sum of all interior angles of a triangle is 180 degree. Okay. Sum of all any exterior angle of a triangle, remote interior angles, and sum of all exterior angle of a triangle is equal to 360 degree. There is no need to write down most of the things you are aware, but yes, in case if you think that there are some formulas or some theorem which you forget, so you can note it down and can keep revising on the next couple of days, let's say 2-3 days. Okay, so ye kar sakte ho. All right, so let's see here. In case if you want me to go back to any slide, just tell me. Okay, now in any triangle, the at least 90 degree. So two of the angles must be less than 90 degree in any triangle. Okay. Also, side opposite is the shortest. Okay. And if two triangles are equal, it means their opposites are also equal. Means angle A is also equal to angle B here. Okay. And if all three sides are equal, then it means that all the angles are also equal here. If all the three sides are equal, then all the angles are also equal here. All right. Now, right angle triangle, we all know Pythagoras theorem. There is nothing too much to explain in Pythagoras theorem here. Now, few things which is very, very important here, that is on the next slide, which might be possible that some of you are not forget it. Okay, that here. If the triangle is an acute triangle, and if angle C is an acute, so if I'm talking about this angle is nothing but that is an acute angle. Okay. So if angle C is acute, so opposite to this side is nothing but AB. So the length of AB square, it has to be less than AC square plus BC square. Okay. So AB square, it must be less than AC square plus BC square if the triangle is acute here. All right. In case of obtuse angle triangle, if the triangle is obtuse, so in that case, the longest possible side, that is AB, it must square of this, it must be greater than AC plus BC square. And in the CAT, you must have seen that on couple of occasions they had checked this properties of acute angle, obtuse angle, as well as right angle also. They have checked all these three properties: acute, obtuse, and the right angle. All right. So I can say here, in any triangle, if you say that one of the side is the largest side, if C is the largest side, okay, let's say C is the largest side. So you just need to remember, for right angle triangle, C square is equal to A square plus B square. For acute angle triangle, C square is less than A square plus B square. And for obtuse angle triangle, it is always greater than A square plus B square. So these are the three very, very, very important formula. All right. So should we move to the next slide? So whatever you think that okay, you need to write it down. Write down all the important things. जो तुम्हें लगता है कि नहीं मुझे चाहिए इसे रिवाइज करना चाहिए, पता होना चाहिए. So you can write down those things. Otherwise, most of the things you guys already know. Just that you need a quick revision here. Now, next point here. Triangle inequality. In any triangle, the sum of the two sides is always greater than the third side, and the difference of any two sides of a triangle is also less than the third side. So, which is very, very important here. Sum of two sides is greater, and the difference of two sides is always lesser than the third side. So, I can say A, it has to be greater than C, B plus A, and C plus A is greater than B. And at the same time, A minus B, it has to be less than C. Mod of B minus C, it has to be less than A, and mod of C minus B less than B. So both of them are the more or less same thing here. Okay. Now let's move to the next point. Perimeter, you all know the formula for the perimeter. Perimeter is nothing but sum of three sides. Semi-perimeter is equal to A plus B plus I, 2 here. Now coming to the important thing, yes. These are the something which we have derived in the class, which also helps in tackling a lot of questions here. Sides of a triangle, any triangle is the semi-perimeter here. So if I say there are three sides of triangle, that is A, B, C, all these three sides, A, B, and C, it is always less than the semi-perimeter. Okay. Now this helps whenever we need to count the number of integral triangles. Okay. So all the three sides of a triangle are always less than the semi-perimeter. Also, the largest side of any triangle, a very, very important property. Okay, we have derived this result. The largest side of any triangle, it will always be greater than equal to P by 3, but it is always less than P by 2. So, yeah. So for any triangle, the largest side should be always in this range where P is a perimeter of a triangle here. Can we move to the next slide now? Please respond, all of you. Keep responding. Okay. Now let's move to the next point then. Okay, now that's another important result. Okay, now if you look at the CAT paper, so most of the questions which was asked in the CAT, it can be solved without knowing this formula. But you know that if you know this formula, you can get the answers quickly. Like once there was a question based on finding the integral number of triangles, even in the CAT as well as in the XAT. Okay, so we know I have discussed two different approaches. One is how to do a counting, and I also told you the direct formula. So these are the direct formula. Okay, so the number of different triangles which have integer side length and the perimeter is n, then it is always equal to n squared by 48 for n is even. And if n is an odd number, then it is n plus 3 whole square by 48. Okay. And the number of scalene triangle, if I need to find out the number of scalene triangle, so in that case, you simply need to replace n by n minus 6 here. And then you need to check, okay, what is n minus 6? If n minus 6 is odd or even, and accordingly, you need to put that in the formula. If n minus 6 is odd, then substitute here. Similarly, if I need to find out the number of isosceles triangle, that includes that includes the equilateral if the equilateral triangle exists. So in that case, the number of isosceles triangle, it is always equal to total number of triangle minus the total number of scalene triangle here. So total number of triangle minus total number of scalene triangle, and that will give me the isosceles. Now equilateral will only happen only if the perimeter is a multiple of 3. क्योंकि equilateral में क्या होना चाहिए, तीनों sides equal है. तो perimeter, if all the 3 sides are integer, it has to be a multiple of 3. और वो एक ही exist करेगा ज्यादा से ज्यादा, बस एक ही equilateral for any fixed perimeter. For example, if the perimeter is 30, एक ही triangle equilateral triangle हो सकता है when all the 3 sides are 10, 10 and 10 here. Okay. Now next thing, if I need to find out the number of triangles, integral triangles in which all the 3, okay, if all the 3 sides are even number, in that case simply replace n to n को n by 2 से replace कर देना है. ठीक है, where n is the perimeter. For example, if the perimeter of the triangle is given as 30 and the question is if all the 3 sides are even, how many triangles are there? So instead of 30, you need to put 15 in these formulas which I have written on the top here. Okay. Now, if I need to find out the number of triangles in which all the 3 sides are odd number, okay, and then in that case you need to replace the perimeter n by n plus 3 by 2 here, n plus 3 by 2. Also, the important thing here is that the meaning of this bracket here, what do you mean by this bracket? This bracket, it means nothing but it is a nearest integer. I need to take the nearest integer, not the greatest integer or the smallest integer, but the nearest integer here. For example, if I'm getting 3.4, okay, after solving this, if I'm getting 3.4, so I'll take it as a 3. Or if I'm getting something like 3.7, I need to take a 4. So you need to take the nearest integer, not the greatest integer or the least integer. That is important here. All right. So this is regarding the finding the integral number of triangles if the perimeter is fixed. Whether I need to find out a scalene or isosceles or equilateral or total, we can use these formulas here. Yes, that's right. ना जतिन n को n minus 6 से replace करना, क्या हुआ, tn minus 6 what, कि n को n के, अगर मेरा perimeter 30 है और मुझे find out करना है total scalene triangles कितने बन सकते हैं, so 30 की जगह सब 4 अगर even number है तो ये पहले वाले फॉर्मूले में substitute करना है. That is what I need to do. All right, this is what we need to do here. Clear now? अगर odd होता तो नीचे वाले फॉर्मूले में पुट करते, same thing. Okay. Some of you might ask, okay sir, अगर एक even और एक odd है, दो हमने क्लास में कर चुके हैं कि अगर एक साइड even है odd है तो क्या करना चाहिए. So just remember, if the sum of these all the 3 sides is an even number, that is the perimeter, तो या तो तीनों के तीनों even होंगे, yes or no, या फिर एक even odd होगा. तो I told you the formula for this. Okay. और total का पता, so total में से तीनों even होंगे, ये subtract कर दो तो automatically you'll get एक even और दो odd number. All right. Similarly, if the perimeter is odd number, so possibilities क्या, या तो तीन या फिर even. तो तीनों odd है, उसके लिए I told you the formula, yes or no, और फिर टोटल में से ये subtract कर दोगे तो you'll automatically get 2 sides odd and 1 side even here. So there is no need to mug up the separate formula, just you need to subtract here and you'll get the desired result. Clear now? Can we move to the next slide? Please tell me now. I hope that you all have noted down. या पहले कर चुके होगे ऑलरेडी, रेगुलर क्लास के टाइम पे किया होगा तुम लोगों ने नोटिस से. Okay, so let's move to the next slide then. Now, the number of different triangles with integer side length and the greatest side equal to c. अब अगर यहाँ है जिसका लार्जेस्ट साइड c है, ठीक है, और ये एक इंटीजर है, so this is my large. अभी तक क्या था, पेरीमीटर गिवन था, अब यहाँ पे एक ट्रायंगल है, उस ट्रायंगल का लार्जेस्ट साइड गिवन है. सो अगर लार्जेस्ट साइड गिवन है, देन यू कैन यूज दिस फॉर्मूला टू फाइंड द टोटल नंबर ऑफ ट्रायंगल्स हियर. ओके, सो अगर बाकी की दो साइड्स ए एंड बी है, so in that case it means this formula is less than equal भी हो सकता है, remember. Okay, a and b is less than equal to, so we can use. And if you remember, I have generalized this for 2 separate cases also in the class, and that is what? This one. So number of distinct triangles with the integer side length and greatest side equal to 2m plus 1. Now this is my largest side, और ये 2m plus 1, अगर ये एक ऑड नंबर है और ये लार्जेस्ट साइड है और बाकी दो साइड ये लेस देन इक्वल टू 2m plus 1 और 2m plus 1 है, एक ऑड नंबर, so in that case the total number of integral triangle is always equal to m plus 1 का whole square. Okay, this will give me the total number of integral triangle, that is m plus 1 का whole square. All right, similarly और इसमें से out of this many 3m plus 1 of these triangle will be isosceles or equilateral. Now equilateral तभी होगा अगर हाँ 3m plus 1 of these are isosceles or equilateral. equilateral केवल एक है. ऑलराइट, क्या लिखा हुआ है यहाँ पे देखो, फॉर्मूले में क्या लिखा हुआ है, यहाँ पे प्लस लिखा हुआ है माइनस, अगर प्लस लिखा हुआ है तो ऑफकोर्स मुझे प्लस लेना है ना, साइन, दैट्स अ प्लस साइन, so it means you need to take a plus sign. Okay, all right, now similarly if the largest side is an even number, एक largest side है and this largest side is nothing but that is my even number, that is 2m, and the remaining two sides are nothing but less than equal to 2m. Okay, the remaining two sides are less than equal to 2m, so in that case it is always equal to m into m plus 1. The total number of integral triangle is always equal to m into m plus 1. All right, now and the out of which 3m आइसोसेलेस और इक्विलेटरल, सो 3m minus 1 जो ट्रायंगल्स होंगे उसमें से वो आइसोसेलेस होंगे, इक्विलेटरल होंगे. फॉर एग्जांपल अगर मैं कहता हूं लार्जेस्ट साइड 6 है, ओके, इफ द लार्जेस्ट साइड इज 6 व्हिच इज इक्वल टू 2 into m and remaining two sides are integers, then how many triangles can be formed? You can simply say the total number of triangles will be nothing but 12. Okay, and out of these 12 cases, how many of them are isosceles or equilateral? So I can say that is 3m minus 1. So m is equal to what here? M is equal to 3. So 3 into 3 minus 1, that is equal to 8. So 8 of these triangles will be isosceles or equilateral, which means 4 of them are scalene. So total 12 triangles बनेंगे जिसमें 6 is the largest side, ठीक है, बाकी के दो साइड either less than equal to 6 है. So out of these 12 triangles, 8 of them will be isosceles or equilateral and the remaining 4 of them will be the scalene triangle. If you know this formula, you can also find out for scalene by taking a difference between these two values here. All right. Now यहाँ पे ये जो formula मैंने बताया था. Now it says the number of different triangles with integer side length and greatest side equal to c and the two sides lesser than c. Now in the previous slides, the two sides can be even lesser than or equal to c. Lesser than or equal to c, but यहाँ पे क्या है, it has to be lesser than c. So if this is my triangle, if this is the side c, other two sides is definitely it is less than c, not equal. In that case you need to use a minus sign sign. Okay, तब ये होता है. अगर ये less than equal to है तो फिर directly c plus 1. Okay, integral value of c plus 1 का whole square by 4. If it is less than c, so you can use this one. So I hope that it is clear. Can we move to the next slide now? चले आगे guys, गरिमा, साई, संतोष, जतिन, Nikita and everyone, Suraj, all of you. Okay. Now, also the number of triangles that can be formed with two n lines of length 1 to n is given by. One of the ways you can use maybe ट्रायंगल इनइक्वालिटी, सम ऑफ टू साइड्स इज ग्रेटर देन थर्ड साइड, उससे केस बाय केस बना के काउंटिंग कर सकते हो, और यू कैन यूज डायरेक्ट फॉर्मूला. अगर मैं कहता हूं मेरे पास एक स्टिक है जिसकी लेंथ 1 यूनिट है, एक दूसरी स्टिक है जो 2 यूनिट की है, एक स्टिक की लेंथ 3 यूनिट की है, एक स्टिक की लेंथ 4 यूनिट की, एक की 6, तो टोटल हो सकता है इनमें से स्टिक्स को लेके. सो दैट इज अ फॉर्मूला यार. इफ द लास्ट नंबर 2n, if it is an okay, the largest one is an even number, and the second formula if it is an odd number. Okay, if odd number of lengths are there or if even number of lengths are there, then we can get in this way here. Okay, so I hope that it is clear. So should we move to the next slide? So these are some rare formulas. Okay, now remember, in the CAT is not expecting you to know these formulas. Okay. But what they are expecting is that whether you can use the triangle inequality or do you know the counting. On the basis of that, can you count the number of triangles and you can tell the answers or not. कैट में यूजुअली बहुत ही छोटी वैल्यूज गिवन होती है सो दैट यू कैन काउंट इजिली ट्रायंगल. बट यस, if you know these formulas, you can get the answers quickly. All right, let's move to the next slide then. Very, very, very important formula. You must have observed we have used this in a lot of questions when we have discussed the CAT 2017, 18 and 19 के पेपर में ये लॉजिक कई जगह यूज किया ना. So in a right angle triangle, the length, this length, if the two of the perpendicular sides are A and B and this is equal to C, hypotenuse C. So this perpendicular length, it is always equal to product of two perpendicular sides divided by the hypotenuse. And we have derived this formula by using the area of the triangle. Widely used, बहुत ज्यादा यूज होता है, बहुत सारे क्वेश्चंस में यूज करते हैं इसे. Alright. Okay. So let's move to the next one now. Okay. Now in any triangles, the ratio of the sides of the triangle, it is always inversely proportional to the ratio of the height on that particular side. So when I'm saying HA, okay, so it means height on side A. HB means what? This is the height on side A. HB means what? That is the height of the triangle. Okay, the height of a triangle on side B from the opposite point. And HC means height of the triangle on side C. So the ratio of the sides of a triangle, it is inversely related with the ratio of the height on that particular triangle here. Or we can say that is the altitude of a triangle on all the three sides here. All right. Next, okay, Heron's formula. We all know that it's a well-known formula. Most of us we know. याद रहता है हम. S minus A into S minus B is equal to S minus C for any triangle. Okay. Now, this is something I also taken one example where I've solved the question without using these formulas, isn't it? इसकी जरूरत नहीं पड़ती है. You can probably, since we know that the ratio of the sides is equal to ratio of height, उस फंडा को use करके you can find out the sides and then you can find out the area. But we can also use it directly, and the easiest way to remember, we all know that Heron's formula is what? If I need to find out the area of the triangle ABC, so क्या करते हैं? Area of the triangle ABC is equal to S into S minus A into S minus B into S minus C. यही होता है ना? So you can also, मतलब how I have remembered this formula, this complicated formula, कोई भी एक याद रखो, that is important thing here. So that is what I have remembered. So ये जो है S minus A, S minus B, S minus C. So ये क्या होता है? Semi perimeter we know that is equal to what? I can say A by 2 plus by 2. The same thing here. So तीन height होंगी ना. So ये जो factor है 1, it's like something like I can say S minus C. ये क्या हो गया मेरे पास? 1 by HA minus 1 by HB plus 1 by HC और ये minus 1 by HA. So दो हाइट का रेसिप्रोकल ऐड करना और तीसरे हाइट को सब्ट्रैक्ट करना. So this is what we do here. And here it is nothing but simply the sum of the reciprocal of all the three heights. And area is also in denominator. So in case if the height of, then use this here. Or you can find out, we know that A is to B is to C is equal to 1 by HA is to 1 by HB is to 1 by HC. So you can find out the sides ratio और उसके बाद कुछ भी आएगा जो भी रेशो और फिर उसको अज्यूम कर लोगे कि A की C की लेंथ है और then you can use the Heron's formula. It totally depends upon you. I have discussed that both the approaches in the classes here. Right. So is that clear? Can we move to the next slide? चले आगे guys. Okay, chalo, let's move ahead. Now, sine rule of a triangle, very important thing. Area of a triangle is always equal to half AB sine C, half BC sine A, and half AC sine B. And for equilateral triangle, this is equal to root 3 by 4 A square. That is the area of a triangle, equilateral triangle, which is root 3 by 4 A square. Okay. Again, another important thing. Okay, ratio of the area is always proportional to the ratio of the sides here. All right. So ratio of the area is always proportional to the ratio of the sides. A very useful property. और ये जो है ये जो हाफ ए बी साइन सी, ये फंडा भी बहुत जगह यूज करते हैं ना, समथिंग लाइक व्हेनेवर द फिगर इज समथिंग लाइक दिस, और ये रेशो गिवन हो इन दोनों साइड से, इन दोनों साइड्स की, सो वी यूजुअली यूज दिस, द शॉर्टकट्स व्हिच वी हैव डन इन द क्लासेस हियर. ओके. So ratio of area is always proportional to the ratio of the bases, because from point C the height of both the triangles are same. So height of both the triangles are same. So ratio of area of these two triangles is here. So if I say this is the ratio of these two is equal to 3:4, so the area will be also 3K and 4K. Same thing. Okay. If the basis is same, then in that case, ratio of the area of the two triangle is always equal to ratio of the height. If the bases are same, then the ratio of area is always equal to the ratio of the heights here. All right. So let's move to the next slide then. Oh, a very, very important one. In any quadrilateral, the product of these two areas are always equal. So I say the product is area is always equal to area x. Okay. So area of W into area Y, it is always equal to area x into z. A very, very important one. This also we have derived this, and we have solved a lot of difficult questions by using these properties in a very short amount of time here. C is to ED. So for example, if I say the ratio of P is C is to ED is equal to P is to Q. So the area of this triangle BC is equal to K into P times, and area of the triangle BED is also equal to K into Q times. जो रेशो बेसिस की है वही रेशो एरियाज की. इवन द रेशो ऑफ एरिया ऑफ द ट्राइंगल ABC, it is equal to, let me say, I can say, let's say P. So ये क्या हो जाएगा, दो ट्राइंगल्स है, इनकी भी एरिया की रेशोज सेम रहती है. Alright. So overall also it will be P is to D. And the ratio of CBD to CAD. Yes, CBD to CAD, that is important. It is always equal to B upon E. Alright. Let me write down here. That is something which you need. So if I say this length AB is equal to what? AB is equal to, I can say take M and equal to N. Okay. If there is a triangle like this one, if the length of AB is equal to M and length of CBD B is equal to N. So in that case, the ratio of area of the triangle CBD. So I'm trying what C. Okay. इसमें point B से जो dropped है line, that is equal to nothing but that is equal to N. Or ACD, the total, it is equal to nothing but that is equal to M plus. So usually ये bases वाले तो रहते हैं, but yes, if you know this thing also, a lot of questions can be done quickly. So if you want to note it down, note कर सकते हो, but I'm sure that पहले note क्या होगा class के time पे. All right. So should I move ahead to the next slide? Please tell me. Now this is also something which can help you to get the answers quickly here. Okay. Area of the triangle AOP. So I can write down here that let's say this is the area A, this is area B, area C, area D, area E, area F. So it basically says that the ratio of A by B, okay, into C by D into E by F, that is always equal to 1. Okay. If there are any from the three corners of a triangle, if you draw the three lengths, you can always say. All right. Or I can say that is A into C into A. Area of A into C into E is equal to area into F. Means alternate areas के products हमेशा equal होते हैं. All right. So A into E into these alternate areas. So the product of these areas is always equal to the product of these areas. So अगर इन 6 रीजन में से किसी एक का गिवन है, सॉरी कि 4 गिवन होता है तो बाकी के 2 फाइंड आउट करने रहते हैं यूजुअली क्वेश्चंस में, तो वी कैन फाइंड आउट इजीली इफ यू नो दिस रिलेशनशिप हियर. Alright. And the ratio of the bases also same thing, because we know that the ratio of area equal to ratio of bases. So ratio of area से ये भी आ जाएगा length, that if the length this is equal to M, this is N, this is P, this is Q, and this is R, and this. So I can say ratio M by N into ratio P by Q into ratio R by S. एक cyclic order में लेना है. M by N is into P by Q in R by S. This is always equal to 1, the length. So out of this 6 length, if or koi bhi ratio is given, so it will be quite useful to find out the others. So M by N into P by Q into R by S is always equal to 1. All right. So can we move to the next slide now? Chale aage. Also, this is OP upon CP plus OQ. Yes. If I say this is A and this is B, this is P, this is equal to Q, and this is R and this is S. So if I consider this triangle AOB, so I can say the length of A upon A plus P upon P plus Q plus R upon R plus S. This is always equal to 1. Not widely used, but yeah, previous जो थे वो कुछ ज़्यादा use होता है questions में, but ये इतना ज़्यादा use नहीं होता है. Okay. All right. So let's move to the next slide then. Raoult's theorem. Usually it is used to find out the area of the middle triangle. Okay. It is usually find out the area. We can use this particular formula to find out the area. Okay. It says if is to FB is equal to R. So if I this is R is to 1, this is S is to 1, and this ratio is equal to T is to 1. And we need to find out the area of the middle triangle. So area of the middle triangle is given by this formula. Okay. This ABC represents area of the triangle ABC. This GHI means area of the triangle GHI. And if all the three sides are equal, then most of the questions which I have seen, it was usually the ratios are always equal. That is R equal to S equal to T. So in that case, it's easy to calculate n minus 1 whole square upon n square plus n plus 1 into ABC. So this formula will give you the answers quickly for the middle triangle here. All right. Okay, guys. So let's move ahead. Two triangles on the same base or equal bases and between the same parallels are equal in area. So if you're drawing two triangles between the two parallel lines, and if the base of all the triangles are same, then their areas will be also equal, and vice versa also result is true. Okay, so you can see that. Also, we have discussed if there are two lines which are parallel, and if I draw triangles in this case, so the area of these two triangles are also equal. So if this area is equal to, I can say X, so this area is also equal to X. So area of these two triangles are always equal. Provided, so in between two lines, between two parallel lines, if you draw the triangle, two triangles with the same base, then these two areas will be always equal here. And we have seen its application in the class. Okay, let's move to the next slide then. Mass point geometry. We have already discussed a lot of questions. We know that mass at point A into this distance is always equal to mass at point B in this distance. And the at C, it is always equal to mass at B, which is known as the mass point geometry also. Okay, let's move ahead. If the two triangles are similar, then the sides of the larger triangle is always k times the side of the smaller triangle. Okay, then the area is always equal to k square. So which means basically that the ratio of area of two similar triangle is always proportional to the square of the corresponding sides. So ratio of area of two similar triangle is always proportional to the square of the corresponding sides here. Okay, this relationship hold for any pair of only for triangles here. And so we can say for a triangle, the ratio of any corresponding sides will be equal to the ratio of any linear measurement. For example, ratio of the perimeter, ratio of the height of the triangle, ratio of the median, everything the sides here. So whenever the two triangles are similar, so area is always proportional to the square of the corresponding sides. But if you are taking any linear measurement like perimeter, height, ratio of height or ratio of medians, they will be always in the same ratios. All right. They'll be also in the same ratios. Okay. Let's move to the next point. Now that is something which is very, very important. ऐसा है कि इसके basis पे I have seen around how many questions? Around 7 to 8 questions in the last 10 or I say like last 15-year CAT paper. Around 7-8 questions तो मैं देख चुका हूँ इस पे based directly. All right. So what does it mean? That is, if it is equal to x, this length is equal to y, and this length is equal to z, which means 1 by z, it is equal to 1 by x plus 1 by y. Okay. Even in CAT also, बहुत बार आ चुका है CAT में भी, based on this. And we can also say the ratio AF is equal to K times X and FC is also equal to K times Y. That is also okay. The length AF is equal to K times X and the length FC is always equal to K times Y. All right. Now, right angle triangle. In any right angle triangle, we know the ratio of the sides. If it is a 45, 45, 45, the sides are always in the ratio 1 is to 1 is to root 2. Very, very important. Okay. Sides are always in the ratio 1 is to 1 is to root 2. In a 30, 60, 90 triangle, बहुत common है, ठीक है. The ratio is always equal to 1 is to root 3 is to 2. So in 30, 60, 90 triangle, the sides are always in the ratio 1 is to root 3 is to 2. Okay. Pythagorean triplet, very, very important thing. ठीक है. The few common Pythagorean triplet, 3, 4, 5 or इसके multiple, like 3, 4, 5, then its multiple are nothing but that is 6, 8, 10, 9, 12, 15. Okay, 4 se multiply and then I can say 15, 20 and 25. All these are very, very common triplets which are used in the exams. And the other is 5, 12, 13, 7, 24, 25, 8, 15, 17, 9, 40 and 41. So these are all Pythagorean triplets. Okay. Also, I told you in any right angle triangle, if all the three sides are integer, if it is equal to A, this is equal to B and C. So out of these three, A and B, two perpendicular side, one of the perpendicular multiple of 3. Okay. And among these two perpendicular side, one of them is always by 4. For example, if I write down the triplets like 3, 4, 5, then I can say iska multiple chhod deta hu. Some different 5, 30, 7, 24, 25. Okay. 7, 24 and 25. Then 9, 40 and 41. Okay. If I can say like this one. So in that case, you can observe out of the two perpendicular, the two shortest sides, one of them is always a multiple of 3. So like 3, 12, 24, 9. All of them are multiple of 3. And one of the side, exactly one of the side is also always a multiple of 4. This is a 4 is a multiple of 4. Okay, 24 is a multiple of 4. 40 is a multiple of 4. And also exactly one of the, among all the three sides, one of them is always divisible by 5. Okay, one of them is always divisible by 5. Like I can say 3, 4, 5, 5. 5, 12, 13, 5. 7, 24, 25 में ये 5 का multiple है. And 9, 40, 40 is a multiple of 5 and so on. And the largest number, which always, I'm talking about always, but which is always divide irrespective of what is ABC, whatever the integral values of ABC, that is 60. So the product is a multiple of 60 and C. Okay, and It is a right angle triangle. It is a right angle triangle here. Okay. So let's move ahead now. Sine rule of a triangle. A upon sine A is always equal to B upon sine B, which is always equal to C upon sine C. So A by sine A is equal to B by sine B, which is equal to C by sine C. Cosine rule of a triangle. ठीक है, cos C is always equal to A square plus 2AB. Rarely used. कभी कभी 5-10 साल में एक आध क्वेश्चन आ जाते हैं based on these logics here. Alright, जहां पे इसकी जरूरत पड़ती है. So this is the cosine rule and the sine rule of a triangle. Cvian. Okay, what is the Cvian? Cvian is basically a line segment. Okay, a Cvian is a line segment from a vertex of a triangle to a point on the line containing opposite sides of the triangle. That is the Cvian here. And the length of the Cvian is known by the Stewart theorem. And what is that theorem? You can note it down. Okay. किसी भी triangle में, now this is a generalized formula. इसका एक स्पेशल केस होता है Apollonius theorem. Apollonius theorem is nothing but a special case of this. Then another special case of this is the related with the angle bisector theorem. So that I'll come across here. But this result is true for any triangle. चाहे वो हो, चाहे राइट एंगल हो, और ये जो लाइन है डी, जिसकी लेंथ डी है, वो कुछ भी हो, वो एंगल बाइसेक्टर नहीं भी हो, कोई भी लाइन है, बट वो सीवियन होना चाहिए. तो वी कैन अप्लाई दिस फॉर्मूला. If it the length of the D, if it is an angle bisector or median, then there is a specific formula for that. That is known as Stewart's theorem, sorry, Apollonius theorem or the angle bisector theorem, which is there on the next couple of slides here. But this is applicable for anyone. Okay. So I can say here B square. ठीक है, B square. It how you can remember that is B square here. So इसके लिए एक निमोनिक में बनाया था पहले. अब मैं ज्यादा डिस्कस B and bomb plus CNC. So I can say bomb plus sink is equal to dad plus man, MAN. So bomb plus sink is equal to dad, and dad is a man here. So something like this one. So you can use this mnemonic to memorize this, but with a little bit of practice, ऐसे ही याद हो जाता है. Okay, when you solve a couple of questions, so already it will be there in the mind. So it is a cross. So B square into M, C square into N. All right, and that is equal to D square into A. The product is equal to product of these three sides, that is M and A. जिस लाइन पे मैंने CVN ड्रॉ किया है. All right, जिस लाइन पे मैंने CVN ड्रॉ किया है. Clear? चले आगे guys. Should we move ahead? Please respond. Should we move ahead? If you guys can hear me, keep responding. Okay, chalo. Let's move to the next slide. Now, next is nothing but, I think it is a what? Perpendicular bisector. So point of intersection of perpendicular bisector, it is known as what? Circumcenter. So we'll discuss few important properties related with the circumcenter here. Okay. So perpendicular bisector of a triangle will meet at one particular point, which is known as the circumcenter. What are the important points related with the circumcenter? So circumcenter, we can say, by taking this as a center, okay, the length OA is always equal to OB equal to OC. So this length OA, OB and OC. If O is the circumcenter of a triangle, in that case, OA is always equal to OB as equal to OC here. And by taking this O as a center, we can draw a circle like this here. Okay. So the circle is nothing but this circle. It is known as the circum circle. All right, guys. So this circle is nothing but it is known as the circum circle here. Now, and the radius of this circum is known as circumradius, and we'll see how to find the circumradius under the different conditions that we'll check here. All right. So we'll check how we can find out the circumradius of a triangle. All right. So should we move to the next slide? Okay. So let's move to the next slide then. Okay. Circumradius of any triangle, it is always by AC upon 4A. And you have seen the question based on this in the cat also. Okay. Circumradius of any triangle, it is given by ABC upon 4A. So that is the circumradius of a triangle, which is ABC upon 4A. Next, also the circumradius of any triangle, it is also given by the sine rule. That is A by sine A, which is equal to B upon sine B, which is equal to C upon sine C, which is always equal to 2R. So A by sine A is equal to B by sine B, which is equal to C upon sine C, and that length will be always equal to twice of radius here. Okay. Now let's see here. Now also the circumcenter of a right angle triangle. That is. So if there is a right angle triangle and I need to find out the circumradius. Last year there was a question based on this in the cat, which is very easy. Okay. So if I say this is equal to A, B and C, so the right circumradius of the right angle triangle, it is always the half of the hypotenuse. So if I draw this line, this is the median. These three lengths will be always equal. Okay, these three lengths. So in case of a right angle triangle, circumradius is actually nothing but the half of the hypotenuse only. And the circumradius of equilateral triangle. Circumradius of the equilateral triangle with side length A is given by A upon root 3. Okay. The circumradius of equilateral triangle with the side length of A is given by A by root 3. So for right angle triangle and equilateral triangle, पता होना चाहिए, important होता है. Okay. C and A by root 3. Now next, if I say location of the circumcenter. Circumcenter of a triangle, it can lies inside, as well as it can lies outside, as well as it can lie on the triangle also. Okay. The circumcenter of a triangle, it can lies inside the triangle. Okay. For acute angle triangle, it is always inside. For obtuse angle triangle, it is always outside. And for right angle triangle, it is always the center of the hypotenuse here. And that's the reason that if I join A to O, तो ये तीनों रेडियस ही होगा ना, इसलिए ये तीनों लेंथ. Okay. Angles at the circumcenter, that is always the twice of this. So angle BOC, if I join angle BOC, so angle A is equal to theta, so this angle will be always equal to 2 theta. Angle BOC, in this case, if it is theta, then this angle is equal to 2 theta. And here it is equal to 90 and this is equal to 180 degree. So angle at the circumcenter is always the twice of the opposite angle here. All right. Now, angle bisector of a triangle are concurrent at a point which is known as nothing but that is the incenter of a triangle. So angle bisector of a triangle are concurrent at a point, and that point is said to be as a called as the incenter of a triangle. All right. All right. So let's move to the next slide then. Relative incenter. Incenter is nothing but by taking this as a center, we can draw a circle. And these are perpendicular, which are all equal here. And the radius of this circle, it is known as in radius. And we'll see what are the different formula related with the in radius, which you can note it down. In radius ke kya formulas hai? Okay. So what are the different formulas with the in radius? In center is always inside the triangle. That is also important. In center is always inside the triangle. So the formula in radius is always equal to area upon semi-perimeter. Circumradius was equal to ABC by 4 times area. Okay. Next one. In radius of a right angle triangle. Okay. Last year, cat mein question tha is pe based. That in any right angle triangle, if this length is A, this length is B, this length is equal to C, then the radius of this circle is एक ही फॉर्मूला, मैं इतने सारे फॉर्मूले याद नहीं रखता हूं, बस मैं सिंपली याद रखूंगा दिस इज इक्वल टू सम ऑफ टू परपेंडिकुलर साइड माइनस हाइपोटेन्यूज डिवाइडेड बाय 2. So this is the radius of the right angle triangle. So right angle triangle and equilateral triangles are important. उसके सर्कम रेडियस के फॉर्मूला इन रेडियस के फॉर्मूले पता होने चाहिए सबको. So this is the in radius of a right angle triangle. Now, the in radius of a equilateral triangle with side length A is given but A upon 2 root 3. Okay. So the in radius of a equilateral triangle with side length A, it is always given by A by 2 root 3. Okay. All right. So let's move to the next slide then. The equilateral triangle, in equilateral triangle, the circumradius and in radius are all in the ratio 2:1. In one of the year, there was a question based on this. I think probably CAT 2007. The in radius of a equilateral triangle with side length A is given by A upon 2 root 3. The equilateral triangle is circumradius and in radius are in the ratio 2:1. All right. Now let's see here. Also, another formula for in radius not widely used. If the height of the triangles are given on all the three sides, the heights h1, 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 h2, h3. So in radius is also given by this formula. 1 by r is equal to 1 upon height on the first base plus 1 upon height on the second base plus 1 upon height on the third base, where small r is the in radius of a triangle. All right, small r is the in radius of a triangle. Now, ये उतना ज्यादा यूज नहीं होता है. In geometry, Euler's theorem states that the distance between circumcenter and incenter. So there are 2 points here. One of the point is circumcenter और दूसरा incenter है. So इसके बीच में distance अगर d है तो कैसे find out करेंगे? Okay, so that is these are two formulas here. You can remember in there. The d square is equal to r into r minus 2r, where capital R is the circumradius. Okay, given है यहाँ पे capital R is the circumradius and small r it is nothing but that is in radius. Okay. So capital R is the circumradius, small r is the in radius. All right. So can we move to the next slide? Okay. Angles at the incenter. Okay. That is important. Angles at the incenter, it is what 90 plus a by 2 or 90 minus a by 2. ऐसा ही कुछ होता है, बताओ क्या होता है? It is always 90 plus a by 2. So if this is theta, this angle is equal to 90 plus theta by 2. So angles at the incenter, it is always equal to 90 plus theta by 2 here. Okay, angles at the incenter is equal to 90 plus theta by 2. All right, let's move to the next slide then. Angle bisector theorem. Very, very important thing. If this length is equal to P, this length is equal to Q, so this length is equal to K into P, and this is equal to K into Q. These are always equal. Very, very important theorem. So angle bisector, P by P is to Q, so the length of this basis is also K into P and K into Q. So in fact, अगर ये basis की रेशो K by P है ना, AB by AC is equal to, so I think the area will be also in this races ना, like अगर M times P है तो इसकी area भी same हो जाएगा, ratio of base is equal to ratio of areas. Now this is what I was talking about. Okay, again it's a nothing but it's a mixture of angle bisector and Stewart's theorem. दोनों को combine करके you can find out the length of the angle. So if I say this is equal to Q and BD into DC, it is equal to K into P and this is K times Q. So the length AD is square. It is simply equal to P into Q minus K into P into K into Q. You should know that multiplying factor. Question में जो भी given होगा, you can use that. और ये फॉर्मूला डिराइव कैसे हुआ है? स्टीवर्ट्स थ्योरम और एंगल बाइसेक्टर थ्योरम जो प्रीवियस स्लाइड पे इन दोनों को यूज करके. ऑलराइट, median, we all know median always divides the triangle in two equal एरियाज, यस और नो? दोनों की एरिया, अगर इसकी एरिया पी है तो इसकी एरिया भी पी होगी. सो मीडियन ऑलवेज डिवाइड्स द ट्रायंगल इन टू इक्वल एरियाज. नाउ the three median of a triangle divide into the six little triangles. So if you draw all the three medians, the entire triangle will be divided into six regions. And in CAT 2019 in slot 2, if you remember, which we have discussed a couple of back only, I think कल ही discuss किया था या परसों, जिसमें ये length given थी, sorry ये area given थी, and you are supposed to find out what is the area of the entire triangle. याद आ, was there in the CAT 2019. The tool of the medians were given, and it was given that if this length, okay, not length, median की length given थी, and you need to find out the area of the triangle. So we are able to find out the area of this triangle, and once you know the area of this triangle, so area of the entire triangle is 6 times of this. All these areas are equal. I think last CAT 2019 slot 2, when we are discussing, you must have seen that. Is that it? We have this property. Okay. Yes. All right. So let's move to the next slide. So median, this is known as the medial triangle. Okay. So whenever I join the midpoints of the two sides, okay, then the length of the that side is always the half of the third side, and it will be always parallel. So इस केस में क्या होता है, अगर ये तो इसकी लेंथ a है, so इसकी लेंथ 2a होगी. If this length is b, this length will be equal to 2b. If this length is c, this length is 2c. And the area of all these four regions are same. Okay, if this area is equal to k, this area is k, this area is equal to k, and this area is also equal to k. ये भी कैट में आ चुका है कि we are the area of the triangle was given, and we need to find out the area of the middle triangle. Now, okay, that is midline theorem that I already explained it to you here, isn't it? That whenever you join the midpoint, the length will be always the half of the third side. So that is given here. And the line will be also parallel. Okay. Yeah, the median to the hypotenuse of a right angle triangle. So if there is a right angle triangle, okay, the length of the median, if I draw a median, okay, then in that case, these three lengths are always equal. So circum radius or ये same ही होता है median का. So basically in a right angle triangle, the length of the circum radius, as well as the length of median, okay, the length of the circum radius and the length of median, both of them are always equal to the hypotenuse by 2. That is true for any right angle triangle. All right, it is true for any right angle triangle. Okay, point of intersection of median is known as centroid, and centroid always divide, so 2:1. Centroid always divide the median in the ratio 2:1. Okay. So while taking this session, I was just thinking, so some of you said in the beginning कि sir algebra का कुछ revision करें. So I thought कि किस type के, I thought कि instead of telling you the formulas, what we can do is I can discuss all the questions from CAT 1990 से लेके 2008 तक का. ठीक है ना? The topic wise, linear equations, quadratic equations, and so on. So you will be, and then maxima, minima, then AP, GP. So you can easily understand what are the type of the questions are there. Is that okay? करें क्या कल? Tell me, you guys tell me. But इसमें time लगेगा, 10 घंटे कम से कम लगेंगे. Are you guys ready? If you guys are ready, so probably 5 घंटे का एक सेशन कल और 5 घंटे, हाँ, सॉल्व करते जाएंगे फटाफट. मैं तुम लोगों को टाइम दूंगा हर क्वेश्चन के लिए 90 सेकेंड. ज्योमेट्री का तो ऑलरेडी सेशन हो चुका है इस पे बेस्ड. मॉडर्न मैथ्स भी ऑलरेडी वी हैव डन. अर्थमेटिक के भी सारे क्वेश्चंस ऑलरेडी कर चुके हैं. एक अलजेब्रा बचा हुआ था. इफ यू वांट वी कैन डू इट टुमारो. नंबर सिस्टम में तो उतना ज्यादा जरूरत नहीं है उसकी करने की, पास्ट क्वेश्चंस. ओके, बट आई थिंक अलजेब्रा में प्रोबेबली कर सकते हैं. सो मे बी मॉर्निंग नहीं, कल नहीं. आई नीड टू चेक मतलब पीपीटीज, उसमें थोड़ा बहुत एडिट करना होगा. पीपीटीज मैंने बहुत पहले ये सेशन लिया था 2012-13 में. आई थिंक 2013-14 में ऑनलाइन लिया था. तो मुझे पीपीटी चेक करने पड़ेंगे कि वो मेरे पास है या नहीं. तो मुझे थोड़ा सा टाइम चाहिए. आई जस्ट थॉट It came across my mind कि when I was taking this decision. So उसे लेके मे बी कल शाम को 6 से लेके रात के 10 बजे तक 4 घंटे और फिर परसों होगा, ताकि मैं कल दोपहर में पीपीटीज चेक कर लूंगा whether it is there or not. हाँ, तो इट्स जस्ट अ सॉर्ट ऑफ रिवीजन. अब पढ़ना कुछ नहीं है. I keep saying now it's time to focus only on your strength areas. अपने strength पे focus करो. That is more important. That's it. Nothing more than that. ठीक है, जो होता है. तो with the help of those questions, you are actually, I'll say it will be just a sort of revision. Okay. सारे फॉर्मुलेज क्या क्या जो यूज हुए हैं कैट में वो हो जाएंगे. इफ यू वांट देन आई विल कीप इट, अदरवाइज कोई जरूरत नहीं है. तो ठीक है, मैं सारे डिफिकल्ट क्वेश्चन हटा दूंगा. आई विल कीप ओनली द इजी और मीडियम क्वेश्चन. इज दैट ओके? Or I can discuss in the formulas then. Leave the questions. We can discuss only the formulas. Okay. Now, the triangle centroid is always inside the triangle. ठीक है. The triangle centroid is always inside the triangle. Centroid of a triangle is always inside. Now, Apollonius theorem. The Apollonius theorem states that if AD is the median, then AB square plus AC square is always equal. So if I say this is equal to P, this is equal to Q. Okay, this is R, and this is S. Okay, so I can say that is P square plus Q square, that is equal to twice of R square plus S square. Okay, P square plus Q square is always equal to twice of R square plus S square. Okay, so that is the median here. Chalo, let's move to the next slide then. Yeah, some of you might have already solved that. Past सारे questions कर चुके होंगे already. Now, this is again, in any triangle, the sum of the squares of the three sides to the sum of the square of a median, they are always in the ratio 4:3. Okay. The sum of the squares of the three sides to the sum of the squares of medians, it is always in the ratio 4:3. Okay. The sum of the squares of the three sides to the sum of the squares of medians are always in the ratio 4:3. Okay. Should I move to the next slide? Okay. Chalo, let's move to the next one then. That is the orthocenter, point of intersection of altitude. It is known as the orthocenter. Okay. So point of intersection of the altitude is known as the orthocenter. And the three vertices and the orthocenter form the orthocentric system. Means what? ये 3 पॉइंट. सो अगर मेरे पास कोई एक ट्रायंगल है लाइक ए बी सी और एक ये एच जो पॉइंट है ये ऑर्थोसेंटर है. ठीक है, orthocenter. So in that case, you can always say if you pick any 3 points, so that is the fourth point is going to be the orthocenter of the remaining 3 points. So I can say if I'm, for example, picking, okay, for example, if I'm picking the point, just a minute. Yes. So if I'm picking the point A, so I can say A is the orthocenter of remaining 3 points, that is BHC. Or if I'm picking the point C, so C is the orthocenter of the remaining 3 points, HB. If I'm picking the point B, then B is non-center of HC. So together, these 4 points will form a orthocentric system. It is known as orthocentric system here. All right. Let's move to the next one then. Location of orthocenter. Orthocenter for acute angle triangle, it is inside. For obtuse angle triangle, it is outside. And for a right angle triangle, it is always the nothing but the point of intersection of perpendiculars. यही होता है. So orthocenter, it can lies inside as well as outside as well as on the triangle. Same as the circumcenter. Circumcenter also it is lying on the triangle, inside the triangle as well as outside the triangle also. Angles at the orthocenter. So simply if I say if this angle it is equal to theta, so इसके opposite में ये जो angle होता है ये होगा 180 minus theta, which means basically the sum of these two angle it is always equal to 180 degree here. Okay, sum of these two angles is equal to 180 degree. Okay. Now in an isosceles triangle, the altitude drawn to the base is the, so in any isosceles triangle, the altitude, it is also act as a median, as a angle bisector, as a property. Okay. And in equilateral triangle, the centroid center as well as in center, all these four centers always coincide here. Okay. So in equilateral triangle, all these four center, that is centroid, orthocenter, circumcenter, and incenter, they will coincide with each other. So can we move to the next slide now, if it is clear to all of you? Okay, let's move to the next one. X circle. X circle is nothing but point of intersection of two. मैं इसका अलग से फिगर बनाता हूँ. X circle is equal to what? If there is a triangle, if you draw the angle bisector on of the angle, okay, let's say theta, this is alpha and alpha, so they meet at a particular point, and this particular point, it is known as the X center here. Okay, can X circle. Okay, so this is my X center, और ये opposite होता है, ये होता है, तो ये भी होता है. That is known as here. And the radius of this circle, it is known as the X radius. And this is given by this one. So for in radius is equal to what? Area upon semi perimeter होता है. So X radius, that is RA. तीन साइड हैं तो तीन X circle बनेंगे. So अगर side A पे बना रहा हो, so that is equal to I can say area of the triangle upon semi perimeter minus side A. Okay. And angle at the X center is 90 minus this. Okay, 90 minus this here. That is the angle at the X center. 90 minus this. Now, so a quick revision here. A lot of people are getting confused. So there are two things here. That is circumcenter. Okay, in center, X center, and then there is a ortho center. So in center, circumcenter, the angle at the circumcenter is equal to twice of theta. In center, it is equal to 90 plus theta 2. At X center, it is by 2 opposite, and at the ortho center, it is always equal to 180 minus theta. So do not solve based on the angles, if you are able to observe. Okay, circumcenter pe twice of theta, in center 90 plus theta by 2, at X center it is 90 minus theta by 2, where theta is the opposite, on the opposite angle on that side to that center, and ortho center it is 180 minus theta. Okay, so should I move to the next slide now? So this is all about the triangle. So till now we have discussed everything related with the triangles. So we can move to the quadrilaterals now. Okay, we can move to the quadrilaterals. So quadrilateral can be convex or concave. Convex, and this is a concave here. So convex quadrilateral is a quadrilateral in which all interior angles are less than 180 degree. Okay, convex quadrilateral is a quadrilateral in which all interior angles are, and quadrilaterals at one internal angle more than 180 degree. So that's the difference between the convex and the concave here. Okay, the interior angles of any quadrilateral adds to 360 degree. The exterior angle of any quadrilateral adds to also 360 degree here. Perimeter we all know, that is plus B plus C plus D. Semi perimeter is A plus B plus C plus D by 2. Area of a quadrilateral, we all know the formula, half 1/2. If you draw one diagonal, then we'll get this figure. So, okay, area of a quadrilateral is also equal to half into D1 D2 sine theta. Quadrilateral is also equal to half D1 D2 sine theta. Okay. Also, area of a general, this is the general formula which is applicable for any quadrilateral. That is to S minus A into S minus C into S minus D. Okay. Into A, B, C, D into cos square by 2. Now, this is the general formula which is applicable to any. So, B plus D is what? Basically, the sum of opposite angles. You take any opposite angles, doesn't matter. Okay, cos square theta is always equal to cos square of 180 minus theta. कोई भी दो opposite angles का sum. So this is the general formula which is valid for any quadrilateral here. Okay. Now, also I have already discussed this, so there is no need to explain this one. The product of two opposites are equal. That is here, the area W is equal to, it is always equal to area X into area Z. All right. Now this is something which is important. If the diagonals of a quadrilateral is a perpendicular to each other, okay, then in that case I can say if this is the length P, this is the length Q, this is X and Y. So if in any quadrilateral the diagonals are perpendicular to each other, so in that case we can say P square plus Q square. Sum of the squares of opposite sides are always equal. So P always equal to X square plus Y square. All right. P square plus Q square is always equal to X square plus Y square. Trapezium. Okay. We all know trapezium. The sum of all the four interior angles of a trapezium is 360 degree. And if these two sides are parallel, so the length of angle C plus angle is equal to 180 degree. Angle B plus angle A is also equal to 180 degree. These are very basics here. Okay. Yes. In any trapezium, we already know that these areas are always equal. Angles between two parallel lines we are triangle. And these two figures, that is white one and the yellow, these two figures are always similar. And using that similarity property, we can solve a lot of questions based on that. Okay. Now, if this is a trapezium and there is a one line which is parallel to this and it divides them in the ratio A is to B. A is to B. So the length of XY, that is A into B2 plus B into B1 upon the sum of these ratios here, that is A plus B. Okay, so this is how we can find out the length of the XY here. Now MN. Now this is the median of a trapezoid where MN midpoint, so it means the ratio is 1:1. So the length MN, it is always equal to half of the sum of these two parallel sides. All right. Mn is always equal to half of the sum of these two parallel sides here. Now, this is what in any trapezium, if this length is equal to x, this length is equal to y. And if you join the midpoints of the diagonals, okay, these are two diagonals of a trapezium, and if you join the midpoints of the diagonal, so this length is always equal of the these two, that is x minus y. And this is also parallel. These three lines will be also parallel here. So that is related with a trapezium. Okay, it is related with a trapezium. Okay, area of a trapezium we all know. Sum of parallel sides into distance between the two parallel sides. Okay, so if for example if it is A and this is B, so area of a trapezium is half of A plus B. Isosceles trapezium. So in isosceles trapezium, the length of the oblique sides or non-parallel sides are equal, and the length of diagonals are also equal. That is very, very important. Okay, in isosceles, the diagonals are equal, the legs are equal, the base angle comes in two pair of equal angles here. So these are the few properties of a isosceles trapezium. Okay, let's see here. Isosceles trapezium, parallelogram. There is nothing here. Diagonals of a parallelogram always, okay, opposite angles are also equal. Also equal. These are area of a parallelogram. It is always equal to what? Base आई थिंक 2018 में क्वेश्चंस थे इस पे बेस्ड. एरिया ऑफ ए पैरेललोग्राम इज ऑलवेज इक्वल टू बेस इनटू हाइट. Also, area of a parallelogram is equal to AB sine theta, where theta is the angle between any two sides. Okay. So area of a parallelogram is also given by the formula AB sine theta, where theta is the angle between two adjacent sides. Okay. Now that is something important here. The sum of the squares of a diagonal of a parallelogram equal to the sum of the square of the sides of the parallelogram. Let me write down here. This is equal to A. This is equal to B here. दिस इज ऑल्सो इक्वल टू ए, और ये भी क्या हो जाएगा, बी हो जाएगा. और ये के डायगोनल है, दैट इज D1 एंड D2. सो विच बेसिकली मींस plus D2 square. Sum of the square of a diagonal of a parallelogram, it is always equal to sum of the squares of all the four sides. A square plus B square plus A square. This is for any parallelogram. So if it is true for parallelogram, so any parallelogram, it is true. Sum of the squares of a diagonals of a parallelogram always equals to the sum of the squares of the sides of a parallelogram. Okay. Then rhombus. So in rhombus, we can say area of a rhombus, it is always D2. Okay. So area of the rhombus, it is always equal to half D1, D2. Area मुझे पता है, diagonal की length पता है, so I don't think we need to spend too much of time on this. Most of us we know that. Diagonals of a rectangles are always equal to each other, and it is equal to the square root of the sum of the length and width of a triangle, and area is equal to length into width. Okay, these are easy. British flag theorem, very important one. If this length it is equal to A, this length is equal to B, this is equal to C, and this is equal to D. So A square plus C square, it is always equal to B square plus D square. P is any point inside the triangle. So if P is any point inside the triangle and all the four vertices are joined to that point, in that case, this is the result is always true. A square plus C square is always equal to B square plus D square. All right. Now, a square, nothing too much to tell you. You all know that already. Perimeter side is equal to S square. Diagonal is equal to S root 2. Perimeter can be written this form also. Area is equal to B square by 2. इसमें कुछ बताने के लिए है ही नहीं स्क्वायर में. Kite, okay, diagonals of a kite always bisect, sorry, intersect each other, and one of the sides will be always equal. ये दो sides equal होती हैं. And area of kite is also equal to half D1 D2. So area of the kite is always equal to half into product of the two diagonals. Area of the kite is always equal to half into product of the two diagonals. Each square and rhombus is a kite. Now this is the questions. अब इन सारे क्वेश्चन के आंसर्स तुम दोगे. You all are going to tell me. Let me see कितने लोगों को याद है. I am not going to tell you. A, B, C, D. There are 8 questions. I'll give you 2 minutes and I'm expecting the answer. So all of you in the chat write down कि A का आंसर ये है, B का ये है, C का ये है, D का ये है, E का ये है, F का क्या है, G का क्या है, H का क्या है. All of you please write down in the chat. I'll wait for 2 minutes. Tell me quickly. Let me see how many of you are able to give me the answers. ओके, देख रहे हैं यहाँ पे ऑप्शन ए साइक्लिक क्वाड्रिलेटरल, नो। साइक्लिक क्वाड्रिलेटरल वाला कुछ और क्वेश्चन है, नो। देखो, ए को क्वाड्रिलेटरल के मिड पॉइंट्स को ज्वाइन करने पे क्वाड्रिलेटरल तो मिलेगा ही, बट वो क्वाड्रिलेटरल कौन सा है? इज इट अ जनरल क्वाड्रिलेटरल और इट्स अ पैरेललोग्राम और स्क्वायर और व्हाट? दैट यू नीड टू टेल मी गाइस. So in the first one, whenever you join the midpoints of the sides of a quadrilateral, we'll always get a parallelogram. Okay, in general, parallelogram के midpoint को join करने और get a parallel. और मैंने एक टेक्निक बताई थी कि ऐसा कोई भी फिगर किसी भी क्वाड्रिलेटरल में अगर इफ द लेंथ ऑफ द डायगोनल्स आर इक्वल, दो चीज बताया था, लेंथ ऑफ द डायगोनल्स आर इक्वल, और लेट मी टेल यू वन थिंग वन बाय वन. Okay, length of diagonals are, so in what all figure the length of diagonals are equal? That you can tell me. That's an important property. In what all figure the length of the diagonals are equal? The length of diagonals are equal in case of which all figure? That is a case of rectangle. Yes or no? In case of rectangle, the total length of the diagonals are equal. In case of diagonals are equal, and in case of isosceles trapezoid, the length of diagonals are equal. Okay, these are the three figures in which the length of diagonals are equal. Okay, and I told you the second parameter, which is nothing but, let me write down here. Diagonals intersect at 90 degree. Diagonals intersect at 90 degree. What all figures are there in which the diagonals intersect at 90 degree? So I think the diagonals intersect at 90 degree, the few figures which are there, that is what? Isosceles trapezium. Not isosceles trapezium, ये वो तो length of diagonals था. So intersect at 90 degree, that is rhombus. Okay, kite, and there is one more figure, rhombus, kite, and the figure जिसमें diagonals intersect at 90 degree. Three figures, the diagonals are equal. Okay, so now if I join the midpoint of all these figures, rhombus, kite, and square, in which the diagonals intersect at 90 degree, what kind of figure I'll get? We'll always get a rectangle. We'll always rectangle. In all the figure, you can remember this way, in all the figure in which the diagonals of any quadrilateral intersecting at 90 degree, we'll always get a, if I join the midpoints, we'll get a rectangle. However, if the length of the diagonals are equal, like in case of rectangle, it is equal rhombus or isosceles trapezium. So in that case, you will get what? You'll always get a rhombus. Isn't it? तो लाइक अगर ये रेक्टेंगल है और रेक्टेंगल के मिड पॉइंट्स को मैं ज्वाइन, ये जो फिगर बनता है वो क्या बनता है? दैट इज ऑलवेज अ रोम्बस. यस और नो? स्क्वायर के भी मिड पॉइंट को ज्वाइन करने पे रोम्बस मिलता है, बट इन स्क्वायर इज स्क्वायर हियर. सो आई कैन से हियर, okay, so in case of rhombus, if I join the midpoint of the rhombus, what will I get? I'll always get a rectangle. Get a rectangle. ट्रेपीजियम के मिड पॉइंट को ज्वाइन करने पे, दैट्स अ जनरल, यू विल ऑलवेज गेट अ पैरेललोग्राम. ठीक है ना? आइसोसेलेस ट्रेपीजियम को मिड पॉइंट को ज्वाइन करने पे जो स्पेसिफिक फिगर मिलेगा, दैट इज नथिंग. रेक्टेंगल के मिड पॉइंट को ज्वाइन करने पे अगेन यू विल गेट नथिंग बट दैट इज अ रोम्बस. स्क्वायर के मिड पॉइंट को ज्वाइन करने पे, and that square is also nothing but what? That square is also a rectangle also, and that square is also a rhombus. And kite के midpoint को join करने पे will always get a rectangle. That's it. So I hope that this is clear to all of you. Any doubts now? No. Now coming to the cyclic quadrilateral, in which case you'll get a cyclic quadrilateral, I will tell you the figure also, that figure in which we usually get a cyclic quadrilateral. All right. So किस फिगर में cyclic quadrilateral मिलता है? Can anyone tell me? और किस कंडीशन में मिलता है cyclic quadrilateral? If any one of you have remembered that, please tell me. Because I think Garima told me that for the question number 1, the answer option question number A, the answer is a quadrilateral, but cyclic, that is not. Cyclic quadrilateral, under what conditions you'll get a cyclic quadrilateral? Tell me now. Okay. So I'm going to tell you. Oh, under what conditions will get here? Let me see. No. What happens here that if there is a no, I'll tell you वो क्या होता है. अगर मेरे पास there is a quadrilateral, and if I draw the angle bisector, no, if I draw the angle bisector, like they say this is theta and theta, another angle bisector, this is alpha and alpha, then there is another angle bisector. Okay, I have this one. This is beta and beta. Another angle bisector, that is gamma. And so this particular figure which is inside, that is always a cyclic quadrilateral. This is a cyclic. So when you draw the four sector on all the four vertex of any general quadrilateral, the figure which will get, that is always a cyclic quadrilateral. So this figure is a cyclic quadrilateral होता है. So I hope that now it is clear. So can we move to the next slide? So let's focus on now, okay, polygon. Let's see the few important properties of the polygon. A polygon with all its vertex angle is here. If all the interior angles are equal, then it is known as equiangular polygon. Okay. If all the sides are equal, then it is known as the equilateral polygon. Okay. Now, all right. Now, few important thing. All the regular polygons are equiangular as well as equilateral also. All the regular polygons are equiangular as well as equilateral also. Now, total number of diagonals in a polygon is always equal to n into n minus 2. Okay, that is equal to n into n minus 3 by 2. That is the total number of diagonals of a polygon. Now, sum of interior angle is always equal to n minus 2 into 180 degree. And in case of a regular polygon, each interior angle is 180 by 9. Last year, CAT 2019 slot 2, there was a one question based on this. Okay. The sum of all the exterior angle of a convex polygon is 360 degree, and each exterior angle is also equal to 360 by n. Now, area of a regular pentagon, area of a regular hexagon, and area of a regular octagon. Hexagon and pentagon, so I have never seen a question based in the CAT. Once in IFT, there was a question related to the pentagon. So that's why I put one formula here. Okay, so area of a hexagon, 2s square. Area of a regular octagon, that is 2 into 1 plus root 2 into s square here. Okay, so that is for regular hexagon and the regular octagon here. All right, so let's move to the next slide. Oh, very, very important, the hexagon. Hexagon can be always divided into the 6 equilateral triangles as well as 3 equal rhombus. And if the sides of the hexagon is there, A and A, so this there are 2 possible diagonal. So the length of one of the diagonal is A root 3 and the length of the other diagonal is always equal to 2A. The longest possible diagonal is twice of A. If you know these facts, a lot of questions related to the hexagon can be solved quickly. Okay. So let's move to the next slide here. Okay, now come to the circle. We all know the length of the arc. That is always equal to theta upon 360 into 2 pi r as well as r into theta. So the length of arc is theta upon 360 into 2 pi r as well as r into theta also. Next one. Okay. If the two chords of a circle are congruent, then the arc they subtends are also congruent. Okay. If the two chords are equal, so the arc will be also equal. And vice versa also the result is true. If the two arcs of a circles are congruent, then the chords that subtend them are also congruent. These are very easy properties. Next one, equal chord of a circle subtends equal angle at the center. So if the length of the two chords are equal, then they will subtend equal angle at the center also. So you can see it here. Okay, we can say that if this angle is theta, then this angle is theta. So two chords of equal length subtends equal angle at the center. Now, the line joining the midpoint of the chord to the center is always perpendicular to the chord. So that is again a very important property. Okay, these two lengths will be same, A and A. Equal chords are equidistant from the center. So if there are two chords whose lengths are equal, say the distance from the center to these two chords will be also equal. Now, common chord to two intersecting circles. Now, this is something which is interesting. Okay. So, the length of this common chord, what are the important points? In the following figure, where the two circles intersect, the chord PQ, it is known as the common chord. Okay. And when you join the length AB, the center. So this center, if the distance between the center of the two circles, it will always bisect the common chord. Okay, and they will meet each other at nothing but that is equal to the 90 degree. So important है, CAT में question आ चुके हैं इस पे base. That is equal to 19 degree. All right, let's move to the next one. Now, a few important thing. Okay, yes. Now, if the two chords are intersecting at 90 degree, okay, if the two chords are intersecting at 90 degree, in that case, you can say P, if I say this is equal to X, this is equal to Y, this is equal to Z and W. So in that case, X plus Z square, W to the whole square. Okay, that is always true. So very important result. Okay, another thing, next point, it says two chords of length 2a and 2b are mutually perpendicular. So I can say, let's say the length of the one of the chord is equal to twice of a, another length of the chord is equal to twice of b. कुछ भी ले लेता हूँ, ठीक है? 2a plus 2b are and if the distance of the point at which the chord intersect from the center of the circle. So अगर मैं ये तो खैर diameter में draw कर रखा, if let's say this is the circle. For example, if this is the center of the circle, so no, this is equal to what? If I join, it is always equal to 2r square. No, it is 2r square, not the 2r ka whole square. Okay. It 2r ka square, not the 2r whole square. This is something different from the previous one. This is the distance from the center to the point of intersection of two perpendicular chord. Okay. Point of intersection of two perpendicular chord. That is given here. Okay. So should we move to the next slide, guys? Please tell me now. All right. Next one. Okay. Rotation. Like if there is a one circle A, you can see there is a circle A of radius A here, and it revolves around another circle B. Then the total number of revolution the smaller circle will make around the bigger circle, it is always equal to the radius plus 1. Okay. So if the smaller circle rotates around the bigger circle, okay, until it returns to its starting point, the total number of revolution, it is always equal to capital R small r plus 1. And if this circle is inside, if this circle is inside, in that case, capital R upon R. So this smaller circle, if it is revolving around this line, if this smaller circle, it rotates on the circumference of the bigger circle inside, then in that case, the total number of rounds covered by this smaller circle is always equal to the ratio of these two radius minus 1. Okay. जतिन इसमें क्या रिपीट करना है? आई सिंपली टोल्ड यू देयर इज अ वन सर्कल, एक दो कॉर्ड है, ऐसे है, एक कॉर्ड की लेंथ 2a है, दूसरी कॉर्ड की लेंथ b है, सेंटर से ये डिस्टेंस c है. सो ये जो c provided these two chords are perpendicular to each other. Okay, provided these two chords are perpendicular to each other. All right. Okay, guys. So let's move to the next slide. ये rotation वाला clear हो गया? We have discussed a lot of questions based on this. Area of a circle we all know pi r square. ये बताने की जरूरत भी नहीं होगी. Area of a circle is simply pi r. Okay. Area of a sector, it is always equal to theta by 360 into pi r. And in terms of radians, it is always half theta square. So area of a sector is equal to theta by 360 into pi r square, and area of a this is equal to half theta r square. All right. We all know angle at the circumference, angle at the center, it is always the half of the angle at the circumference. Yes or no? So if this angle is equal to 2 theta, angle at the circumference, it is equal to theta. So angle at the center, it is always the half of the angle at the circumference, theta and 2 theta. अच्छा उल्टा लिख दिया मैंने. Yes, theta and 2 theta. Any angle inscribed in a semicircle is always 90 degree. Okay, angle inscribed in a semicircle is always equal to 90 degree. Next point. Okay. Any two angles that are inscribed in the same arc are always equal. So angles subtended by the same chord or the same arc at the circumference, they are always equal. Now this is a very important thing. So the measurement of the angle formed by two intersecting chords. So if there are two chords, is the average of the arc intercepted by the chord. So if I need to find out this angle, let's say this angle. So this x represents the angle subtended by arc PQR at the center. For example, if I say there is a center of a circle. Okay. If I say there is somewhere there is a center of the circle. So if I say angle subtended by arc QR at the center, it is equal to x. And the angle subtended by arc PS, it is equal to y, or it can be chord also. Then this particular angle, it is always equal to x plus y by 2. Okay. So this is the angle point, okay, angle at the point of intersection of two chords. So angles at a point of intersection of the chord is simply the average. Okay, it will be simply the average of the angle subtended by these two chords at the center. Now, if it is outside, if the two chords are meeting outside, so in that case, it is always equal to the difference between, like at the center, this arc or chord is subtending an angle A or chord subtending angle B. So angle Z, it is equal to nothing but that is equal to half of B minus A. So if it is inside, it is always equal to A plus B by 2. if the two chords are intersecting inside the circle. If they are intersecting outside the circle, then it is always equal to half of B minus A. In that case, it is always equal to half of B minus A. All right, let's move to the next slide then. Okay, that's it. So we have done till circles. So can we move to the mensuration? उसके भी formula discuss करने हैं. Geometry के तो complete हो गए. All the important formulas and theorems I have discussed it. So do you want me to discuss the mensuration part also? Please tell me. Coordinate geometry and trigonometry. ये तीन चीज और बचा. Mensuration, coordinate geometry and trigonometry. So we discuss those also. Okay, so just give me maybe another 20 to 30 minutes. We'll be able to complete that. We can discuss that. Just wait. And I'll start the another PowerPoint presentation. I think it got hang. No, अच्छा सर्किल की अभी भी है इसमें. Okay. So that we can. Okay. So now let's see. So properties related with the properties tangent. So what are the properties of the tangent? We can see that. Okay. So if this is a tangent, so if this angle is, then angle at the center, it will be always equal to 2 theta, where this line Z is nothing but it is tangent to the circle. If the line Z is tangent to the circle, then this will be the case. Okay. Now, next point, alternate segment theorem. That is something which is important here. Okay, just a minute, guys. Yes. So alternate segment theorem here, I can draw it, figure here and here. So if this angle is theta, so any angle drawn in its alternate segment, that will be also equal to theta. So this angle is also equal to theta here. So this is known as the alternate segment theorem. Okay. So this is known as the alternate segment theorem. So you can see this is alternate segment theorem. Now few important related property with the alternate segment theorem. So जहां भी tangent दिखाई दे तो alternate segment theorem strike करना चाहिए. Like ये अगर angle theta है और this line is a tangent, so इसके alternate segment में ये angle भी theta होगा. Or the figure like this one. Okay, if this is theta, so alternate to this segment is this. इसके alternate में ये segment है, so this angle is theta. Alternate to angle phi. Alternate segment to angle phi is this one, so this angle is also equal to phi, provided this line is a tangent to. Okay, this line is a tangent to a circle. Now, these are two very common figures related to the alternate segment theorem. If there are two circles which are touching each other, they can touch each other either internally or externally, like in this case here, I have drawn. So the two circles can touch each other either internally or externally. So if they are touching internally, so alternate segment theorem is important here. So ये दोनों angle, ये छोटे वाले के लिए alternate segment पे और ये बड़े वाले के लिए alternate segment पे, theta and theta. And same thing here. Okay, I can say these two angles are equal. Why? Because these two are vertically opposite angles, phi and phi. Okay, so this phi and phi are vertically opposite angles, or इसके alternate segment में these two angles will be also phi and phi. So that is known as the alternate segment theorem here. Okay. Also, here, same thing. What is the angle, this particular angle? So if I'm saying angle BC, so angle B tends at the center, let's say theta, or angle, and BD subtends this angle as alpha. So this angle is always equal to alpha minus theta by 2. Same thing. We have discussed like there were two chords. Yes or no? तो उस केस में क्या था? Half of A minus B. So अगर एक chord है, sorry, और एक secant है और एक tangent है, तो इस केस में भी half of A minus B होगा always. Next point here. Okay. If P and PB are the tangents from point P, then the length of these two tangents are always equal here. PA is always equal to PB. So length of the two tangents from the point P, that is, they are always equal. So PA is equal to PB. Now, the direct common tangent, the formula. So the direct common tangent formula, it is always equal to the square of the distance between the center of the two circles minus R1 minus R2 whole square. So this is the formula for the direct common tangent, C1 whole square minus R1 minus R2 ka whole square. So this is the direct common tangent. Then there is a transverse common tangent. So the only thing which you need to keep in mind in direct common tangent, it is the difference of the two radius. Whereas in case of transverse common tangent, it is the sum of the two radius. So these are the formula for the direct common tangent and the transverse common tangent here. Okay. Now these are different tangents here. No? Like if the two circles are external to each other, in that case, there will be total of two direct and two transverse. In the second case, ये दो direct हैं और एक common है. If the two circles are intersecting, then you will get only two direct tangent. If the two circles are meeting inside, touching each other, and they are inside, only you act on. और एक दो concentric circles हैं, तो इस case में there is no direct common tangent. So these are the number of direct common tangent with respect to different figures here. All right. Okay, now this is something interesting. If the radius of this is equal to P, the radius of this is equal to Q, and this is the radius is R. If there are three circles which are touching in this fashion here, so can you tell me the relationship between these three radius? There was one question also last year, CAT 2019, direct question था. So बता सकते हो, what is the relationship between the radius of these three circles? Anyone who can tell me the relationship between the radius of these three circles? I'm just waiting for responses. Let me see. There was a direct question in CAT 2020. That is nothing but 1 upon root R. It is always equal to 1 upon root P. Yes, upon 1 upon root Q. Not this one. These are in roots. 1 by root R is always equal to 1 by root P plus 1 by root Q. Now, if the three circles are touching in this fashion, then what is the relationship between their radius? Let's say this radius is equal to P, this radius is Q, and this radius is to R. What is the relationship between these three circles now? Okay, here it is nothing but what is the here? They will always form a series GP. So Q square, it is always equal to PR. Okay, Q square, that is equal to PR. Or you can say Q is equal to root PR. So both other figures are important. The results are also important. Okay, another very common figure, बहुत बार CAT में आ चुका है. If the radius of this is capital R and the radius of small r, so if there are two circles which are touching each other and there is a one tangent है, कोई जरूरी नहीं कि स्क्वायर हो, कुछ भी हो, बट एक ऐसा फिगर होना चाहिए कि एक छोटा सर्कल और एक. So what is the ratio of the radius of these two circles? It's a very common figure in the CAT. There were a lot of questions based on this figure. Yes. So ratio of capital R to small r, that is always equal to root 2 plus 1 upon root 2 minus 1. That is the ratio of these two here. Okay. Root 2 plus 1 upon root 2 minus 1. So can we move to the next slide? Now, last theorem of this one, power of point theorem. Okay. So we know that power of point theorem ना क्या होता है? XA into XB, it is always equal to XC into XD. Or in the second figure, the length PA square, it is always equal to PB into PC, and PB into PC is also equal to PD into P. So very important theorem. Last year there was a one question based on this also. Power of point theorem. Okay. Now this is important here. So pay attention. If the perimeter is for a fixed perimeter, okay, if the perimeter is constant, then the area then with the half size will always be moved to the polygon with number of sides. Okay. So I can say if the perimeter is constant, if I say the perimeter of equilateral triangle, square, pentagon, hexagon are equal. So in that case, the area of the equilateral triangle is smaller. Then the area of the square is more than equilateral triangle. Area of a regular pentagon is more. Area of a regular hexagon is more here. And if the largest one, so on, and it will be always circle. Okay. You can say circle is a polygon with infinite sides. Regular polygon with the infinite side. So that is the case if the perimeter is constant. So if the perimeter is constant, so area will keeps on increasing with the increasing number of sides of a regular polygon. However, if the area is constant, then the perimeter will keeps on decreasing here. That is the reverse. So for any fixed area, the perimeter of lesser number of sides will always. Okay? So if the area is constant, then the perimeter will keep on decreasing with the number of increasing number of sides. तो कैट में आ चुके इस पे बेस्ड क्वेश्चन सो इंपॉर्टेंट है. So I think that completes our circle also, or I can say the geometry portion. So can we move to the mensuration now? There are not too much of the formulas are there in the mensuration. Should we move ahead? Please tell me. So let's move to the mensuration here. अच्छा एक cyclic quadrilateral, tangential quadrilateral. So this particular circle is known as the tangential quadrilateral. And what are the few important properties of the tangential quadrilateral? We can say here. This circle is called as the incircle. It's known as incircle, called nothing but that is the in radius here. Okay. Now that is a circle can be inscribed in a quadrilateral. A circle can be inscribed in a quadrilateral if only if the angle bisector of the four angles of a quadrilateral are congruent. Means all the angle bisectors are meeting at the same point. Okay, all the angle bisectors are meeting at the same point. So if I'm drawing the angle bisector of all the four, they will meet at a same point. Then only we can draw the in circle inside a quadrilateral. Another important properties of in circle, okay, that ये मैंने already बना दिया यहाँ पे, ये सारे angle bisector है. Right. Yes, now that's an important property of any tangential quadrilateral. Sum of opposite sides are equal. So if this length is P, this length is Q, this is X, and this is Y. So P plus Q. Okay, guys, the value P plus Q, it is always equal to X plus Y. Okay. So P plus Q is always equal to X plus Y. All right. Now, in radius of this circle, it is also equal to area upon semi-perimeter. So A and S, area and semi-perimeter of a what? Quadrilateral. It is same as the triangle. But instead of area and semi-perimeter of a triangle, we'll consider area and semi-perimeter of a quadrilateral here. All right. Now, cyclic quadrilateral. In a cyclic quadrilateral, the sum of the opposite angle is always equal to 180 degree. And also the sum of the cos of opposite angles, that is, it is always equal to cos of A plus cos C, and that is always to 0. So cos B plus cos D is always equal to cos A plus cos C, and they are always equal to 0. Area of a cyclic quadrilateral, we all know, root of S minus to S minus C to S minus D. That is the area of the cyclic quadrilateral. Ptolemy's inequalities, sum of product of opposite sides are always greater than equal to the product of diagonals. So if I say this is equal to A, this is equal to B, this is equal to C, and this is equal to D, and the diagonals are X and Y. So sum of product of opposite sides, so that is A plus A into B plus CD, it is always greater than equal to A. And for a cyclic quadrilateral, they are exactly equal. So A plus C. So for cyclic quadrilateral, AB plus CD is always equal to XY. All right. So that is written here. That is AB plus CD. Sorry, यहाँ पे figure में A and C are opposite. So AC plus BD, and that is always equal to product of diagonals. Now diagonals of a cyclic quadrilateral अगर length find out करनी है. So if I need to find out the length of the diagonal BD, so कैसे याद करना है, I'll tell you कैसे याद कर सकते हैं. So अगर कोई भी length find out करनी है BD, so the two adjacent sides of this diagonal is AD, and the two adjacent sides on another side of the diagonal is BC. So in the denominator it is equal to AD plus BC. जो भी adjacent sides के combinations बनेंगे, ठीक है ना, diagonals के opposite में. So if the length diagonal is BD, so adjacent, okay, एक side में A और D है, एक side में B और C है, so ये denominator में आ जाएगा. अब बाकी सारे combinations you can put in the numerator, like AC, A into C plus B into D, and plus A into B plus C into D. क्योंकि ये जो टर्म A है, ये किससे मल्टीप्लाई होगा? C से मल्टीप्लाई होगा, B से मल्टीप्लाई होगा और D से मल्टीप्लाई होगा ना, तीन कॉम्बिनेशंस बनेंगे. सो दिस इज द वे यू कैन रिमेंबर दिस. ऑलराइट, लाइक अब मुझे लेंथ AC फाइंड आउट करना है, तो डिनोमिनेटर में ये 2D प्लस A इंटू B आ जाएगा. सो आई एम राइटिंग डाउन इन द डिनोमिनेटर इट इज इक्वल टू AB प्लस CD. अब न्यूमरेटर में A के साथ और क्या आ जाएगा? AC प्लस समथिंग और एक AD प्लस समथिंग. अब AC हो गया तो बाकी दो BD बचे, इधर AD है तो इट मींस BC होगा और इसका स्क्वायर रूट. सो दिस इज हाउ यू कैन मेमोराइज दिस, द लेंथ ऑफ, sorry, the diagonal length of the diagonal of a cyclic quadrilateral. All right, so I hope that it is clear to all of you. So can we move to the next part? Okay, another thing, the area of a cyclic quadrilateral, कोई भी cyclic quadrilateral, ठीक है, is the maximum possible for any quadrilateral with a given side length. So if there is any quadrilateral, एक general quadrilateral given है जिसकी side है कि okay, ये 1 है, ये 2 है, ये 3 है, ये 4 है, और मुझे क्वेश्चन है कि व्हाट इज द मैक्सिमम एरिया ऑफ दिस क्वाड्रिलेटरल. तो इस क्वाड्रिलेटरल की एरिया मैक्सिमम तब होगी जब ये साइक्लिक होगा. ओके, तो फॉर फाइंडिंग द मैक्सिमम एनी एरिया ऑफ एनी क्वाड्रिलेटरल विद अ गिवन फोर साइड वी नीड टू यूज द फॉर्मूला ऑफ cyclic quadrilateral. All right, so this will give us cyclic quadrilateral. That's it. So that completes our geometry here. So should we stop here now? Mensuration और coordinate trigo कल करें, or you want me to do today only? So we revised all the important formulas and everything related with the quadrilateral, circles, polygons, and everything. क्योंकि ये सारा चीज रिवाइज करने का थोड़ा याद भी रहना चाहिए ना, तो सारी चीज I can take this as another maybe half an hour. That's not an issue, but you tell me, what do you want? Should we stop here or should we continue? बट ये सारे फॉर्मूले तुम लोग खुद से भी एक बार रिवाइज कर लेना. I don't know whether you guys have made the notes or not earlier. Yeah. Okay. Stop. ठीक है. Formulas and theorems. Lots of formulas, lots of theorems. ठीक है. All right, guys. So let's stop here. So good night to all of you. So I'll schedule a session tomorrow at also in the evening 9 o'clock. ठीक है. See you all tomorrow. So was it useful? पहले तो ये बताओ, useful था कुछ या नहीं था? क्योंकि we were just discussing only the formulas, no questions, nothing. कुछ रिवाइज हुआ? Useful. Okay. So I'm just discussing only the formulas, nothing. That's it. क्योंकि ज्योमेट्री एक ऐसा टॉपिक है जिसमें ज्यादा फॉर्मूलेज होते हैं और किसी में नहीं है ये. Alright guys, so good night to all of you.